last time we were here, the little computer thing wasn't working in things. It's very smooth, the podcast that was made for the class period that you weren't here. So that was very smooth, and it's, if you want an excellent review for this quiz, if you're not sure, is to watch that podcast. And you can fast forward to the interesting parts or whatever you'd like to do. And that's YouTube Chemistry with Dr. Smith. Okay. Today is pretty much the last new thing we're going to talk about before our exam, and that's getting molecular formula from percent composition. And this guy, Lavoisier, I'm not a very worldly person. I don't know how to pronounce French too well. Maybe someone here does, but they had some ideas that the active ingredient in like liquor and wine and things, these fermented foods, had some carbon in it, some hydrogen, some oxygen, and then they did some experiments and they got the ratios, how much carbon, hydrogen, and oxygen were in there. Then another guy did some work and he figured out, hey, this is actually what's in beer, wine, the active ingredient, ethanol. Okay. Which one of those, Bianca Munoz, is the percent composition? Which one? Bianca? Which one is a percent composition? Probably the one with the percents, right? Okay. So what we're going to do is get the molecular formula from the percent composition. So they're going to give us this. We don't need to figure it out. But we have to figure this one out. Just what is the formula for that molecule? Okay. And that's the big goal for today. So we need a game plan. Here's our game plan. They give us the percents. Great. Done. They give us all this stuff. And what we want to get first is something called the empirical formula. And then once we get the empirical formula, we're going to jump to the molecular formula. But what is this? Empirical formula? What is that? Gloriana, do you know what that is? It must not be the right answer because we have to keep going. They're both formulas. Why go through the work of getting a formula and then get another one? Why not get the right one in the first place? What is an empirical formula? It's the simplest, does anybody know? It's the simplest integer ratio, right? Like if our answer was, pretend our answer is, I don't know, P4O10. Now these all right, P4O10. With molecules, do we have the simplest ratio in the chemical formula? Right? No, we got to keep it that way. P4O10, tetraphosphorus pentoxide, is that actual big molecule. There's 4 phosphoruses stuck together, bonded, and how many oxygens? 10. So that's what the actual molecule is. But the empirical formula is the simplest ratio. It would be P what, O what? P2O5. That's the empirical formula. It's the simplest ratio. So our goal in this is to do these 3 steps, get the empirical formula, and then we're going to get the molecular formula, okay, by following these little steps up here. So let's see if we can follow them. Let's see what's going on here. Let's get rid of all this stuff, clean it up, and just see if we can follow it. Here's our first question. A compound contains 80% carbon, 20% hydrogen. The molecular weight is 60 grams per mole. So looking at this, Jacqueline, we're supposed to do I am right here in the game plan. Assume 100 grams. Okay, that's nice, but if I assume 100 grams, then how much carbon and hydrogen would I have then? Jacqueline Guerrero. How much would I have? Yeah, 100 grams total. And it's 80% carbon. How many grams of carbon would I have? 80. That's why you assume 100 grams. Because then all you do is change all the little percents to what? To little g's, right? That's why you assume 100 grams. Because does it matter how much of the stuff you have? Would you always have the same chemical formula? If you have a drop of water or a gallon of water, is it still H2O? Yeah. So let's assume an amount that's really easy to use. 100 is the easiest. So if you assume 100 grams, you're going to have 80 grams of carbon, and you're going to have 20 grams of hydrogen. Now I'm writing them way on the side and spaced out because I know that I have to do step 2. I have to convert to moles. So, Christian, how do you go from 80 grams of carbon into moles of carbon? What would you do? Get the molar mass. All right. And where is it? 12.01 about? Okay, he's right. Everybody, the 12.01 grams goes on the bottom. All right, so 80 over, I have a calculator. 80 divided by 12.01, and I get about, that sign of the devil. Did you know, well, that's another story. That's really not, they really think it's 616, not 666. I don't know if you knew that. But anyway, so there's, I should write moles to C. And then the hydrogen. Okay, Janet, what's the molar mass of hydrogen? What is it up there? 1.007. Yeah, let's just round to 1.01. And we probably shouldn't do much rounding, but things work out better if you don't do too much rounding. But okay, 20 divided by 1.01. 20 divided by 5. I get about, did you get about 19.8? Okay, so we have about 6.66 moles of carbon, 19.8 moles of hydrogen. Jessica Perez, we're supposed to do what next? Divide by the smallest. Okay, well, divide this one and divide this one by what? By the smallest. They're after ratios. I don't know if that's much of a hint. Divide it by, you look through all the ones that we have, all the moles that we have. Here we only have 2 to pick from. But you look through all the moles that you calculated, pick out your smallest one, and that's the one you divide through by. So we'll divide through by the 6.66. Okay, so here we'll get 1, and the 19.8 divided by 6.66. Did you get about 2.97, hopefully? That's what I got, about 2.97. So what this means, we're done with our empirical formula. You can write C, H, whatever you get, you write a 1 down there and a 2.97 there. But they're going to want you to round the 2.97 to 3. Yeah. So you really shouldn't say CH 2.97. You should really say CH3. Yeah, it would. Because the convention is they want whole numbers there. Because you have to have, the empirical formula is this number of carbon atoms for every how many hydrogen atoms. So, but in experiments, things never come out perfect. That's why you never get whole numbers. You should, but there's always experimental error and things. But so the simplest ratio is CH3. That is the what formula? The empirical formula. So we'd be done, but there's a part B. Oh, fine. Okay, the part B says, what is the empirical weight? What is the empirical weight? Now, let's get used to something. MWT, because in this last step, they're preparing us for this last step. You have to get this little n. Because right now, we're right here. We have the empirical formula. We're after molecular formula. That means you have to get this little n. What's MWT? What is it? Molar weight, molecular weight. Okay. What's EWT? Empirical weight. So we have to divide molecular weight by empirical weight to get this little n. So we're after EWT. Now to get molecular weight, right, that's adding stuff up on the periodic table. What's empirical weight then? Oh, man, you can't say it any better. The empirical formula's molar mass. Perfect. The empirical formula's molar mass. So that's what EWT is. So if EWT is the empirical formula's molar mass, Yvette, how would you get it? Yeah. So we would add up how many carbons? 1. And how many hydrogens? 3. So carbon was 12.01 plus 3 times 1.01. And we would get... It's sad I have to do that on my calculator. 15.04. At least it slows me down, I guess. Okay. There is our empirical weight. Is everybody with me so far? That was part B. So really all we're doing is breaking our game plan into steps here. But the last question is, what is the molecular formula? So as you go back up to our game plan, clean it up a little bit. What is our molecular formula? This thing. To find n, right, we have to find little n and multiply by the subscripts or something. Well, let's find this little n and see if it makes any sense here. This little n is supposed to be molecular weight all over empirical weight. Well, we found the empirical weight is about 15.04. What's the molecular weight? It's the 60. So the 15 is the empirical weight, all right? The molar mass of the empirical formula, the simplest ratio. The 60, that's the molar mass of the right thing. So it's definitely going to be bigger. So that's about 4, isn't it? Okay. So we get 4. So if we get 4, what is our right answer? We're off by 4, Lauren. What's our right answer then? The empirical weight, that answer's off by a factor of 4. That means you have to do what to these subscripts? It's not CH3 anymore. It's, here's the only hint I gave you, is multiply little n times the subscripts. What subscripts? These guys. Right? So if we're off by 4, it's not CH3 anymore. Everybody at C4H12. Now, no one ever does this because everyone wants to get done fast and move on to the next question. But you should really prove it to yourself that you're doing this right. If you find the molar mass of C4H12, you better get what? You better get what? You better get that 60. All right? You better get, come on. You better get that 60. Otherwise, you did it wrong. So 4 times 12 is 48. You know, and each carbon is 12. It's 60. You know, it's not going to be perfect. It's going to be like 60.01. But it's 60, right? It's really, really close. So it works. Okay? So that is our game plan. This is what you need to remember. Is you need to remember this game plan to get into to go from percent composition all the way to molecular formula. They give us percent composition. First thing you do, assume you have 100 grams, right? Convert to moles. And how do you always convert to moles? Use what? Molar mass on the periodic table for each element. List them all out, nice and long, so you can list them all out. And then we're going to divide through by the smallest number of moles that you get. Then you're done. You have your empirical formula. Okay, now I'm going to set you off on your own here, but I want to make things look a little ugly. Let's say we didn't get, let's go back, and because this is going to happen to you. Let's pretend we divided through here, because you always have to divide through by the smallest, right? So you get some numbers here, right? You divide through by the smallest, and let's play with this a little bit. After you divide through by the smallest, let's say you get 1.25 and 3. Right? So your empirical formula, your little subscripts, should be 1.25 and 3. That's after you divide through by the smallest. Do you round the 1.25 to 1? Or is that too much to round? 0.25 is too much to round. Right? But so how do you handle this? Remember, these are ratios. So you have to multiply both these numbers, multiply both of these by something to get a whole number. And that is going to be your ratio. What would you multiply these by? 0.25 times what will give you a whole number? 0.25 is really a fourth, right? Because it's 25 over 100, so that's a fourth. So you'd multiply by 4. So my answer here would be a 5. So I'd have to multiply by 4. I'd have a 5, and I'd have a 12. So my empirical formula would be C5H12. That's one case. There's another scenario. 0.25. What could be another scenario? You know these. You just haven't thought about it. What if you got 1 point what? What's another one? 1 point. Hopefully that one won't come up. 7.75 won't come up. Thank goodness. How would you turn 3/4 into a whole number? Ugly. Not that one. That one won't happen. Thank goodness. What's another one that will happen though? 0.5 is definitely going to come up. Okay. You divide through by the smallest. You get something with a 0.5 and another number. Now you got to multiply by 2. All right? And then you end up with 3 to 6. I think there's only one more. There's only one more. It's not that common, but it'll show up. 3, 3, 3, 3, 3. This just keeps on going. Then you multiply by 3. Because then you get 3.999999999. Right? So you have to multiply by 3 in that case. Make sense? Okay, so you've got the game plan. You've got some questions. Here's one. And we have about 20 minutes, so what I'd like to do is something different. Just to see how you like it. If you don't like it, we won't follow through on it. We're going to take advantage of all this board space up here. So the rules of the game to make this work, and this works. In the past, it's worked. Everyone does their own work, but yet, you know, you can look around and look at Gloriana's the whole time if you want. I don't care. But the point is everyone's writing out their own stuff, and everyone's helping each other out. Okay? So bring this up with you, and let's see how this works. Grab some board space, and there's chalk. I've got a lot of chalk. If there's not any around at your area, I've got a lot of new chalk. And I've got a lot of erasers. spread out as much as you can. And well, we have too many people. One of you jump over to that little thing right there. There's two. You guys are crammed in there too tight. You need a lot of space to work these problems out. Christian, go to that one. Christian, go to that.
Okay.
You have your own board. Okay. Slide. Well, I'm just going to help you out a little more. Slide down. Slide down. Slide down. You need to slide down a little bit. So then you have this thing. Okay. Maybe slide down too, Janet. And then, because these guys are, slide down a little bit, Gloriana. Okay, so they need a lot of space. Okay. Everyone's got some pencil. Chalk. Okay. So the first thing you do, convert. Just change those little percents to grams. And if you're not sure, just talk to your neighbor. No, we're working together. There is no cheating. Okay. Right. And now you just got to convert every one of these to moles. All right. So look up the carbon. He's 12.01. Yeah. Good. First step, convert to moles. Right. And you're going to need your calculator for sure. Sorry. Don't forget about oxygen. You might give it, hopefully he's not going to give you a smaller answer, right? Because you have 28.5 grams of oxygen to do yet, too.
Okay.
Yeah. This is all right. All I'm going to say is just it helps if you write out the units more, so you can see how that they're canceling, because it's just going to get more and more complicated as we go. So no, you're fine. You're fine. Keep going with this. Just next time you do it, just like she's got it. See how you can see how the grams of carbon canceling. But you're fine. Keep going. Okay. Now the next step was you got it. Good.
Would I just keep it at 4?
Yeah, because it's not a point. The ones that you have to worry about are the 0.25, 0.5, and the 0.333. Then you have to multiply them all by that number.
Okay.
Good. And you have the empirical formula. Yeah, good. So you can keep going because you have the handout. So everybody has the handout, so just keep going. Several folks got C3H4O as the empirical formula. Great. I think that's what they got too. So then you divided the two. Yeah, it looks great. You go on and try the next one. Good. Yeah. Now what if you would have got 4.25? Then what would you have done?
Divided by 4.
Not divide by 4.
Multiply by 4.
All of them by 4.
All of them.
And then you put those down. Good. So keep going. That's your empirical formula. Good, we got it. Okay. Let's just pretend this was 1.5. What would you do then?
By 2.
Multiply everything through by 2. And that'd be your new empirical formula. Right. Good. So keep going. I think, Lauren, what you need to do. No, I think so. That's the only reason why I know.
Okay.
Because I see a lot of folks carrying out more digits than you.
Okay.
And then it looks a lot better. Because 3.83, right?
Yeah.
She ended up with, what, 3.006.
Okay.
So I'm not sure where it is. No, that was this one. Yeah, she got 4.013. It's really obvious it's 4.
Yeah.
Yours, it's not so obvious it's 4. But you have to round to 4. Because the only one...
So I can? Because like this one I can round to 3?
That one you round to 3. This one goes to 4.
Let's use 1.
So the only ones you can't round are the 0.3s,
Okay.
0.25s, and the 0.1s.
Okay.
Yeah, just carry a few more digits. Carry a few more digits, because then it'll be safer. Keep going if you get it. If you match, especially if you match folks around you. Try the next one. There isn't a next one? Yeah, there is. Yeah, just erase it and start over. Yeah, there's one over there. I'll get you some more erasers. Now, just to let you know, the psychologists know that if you explain this to somebody else, you are going to remember it much, much better. So ask the folks around you, because you're really helping them by having them explain it to you. So you're both benefiting. Oh, it's 7.2.
Oh, point. Oh, okay.
There you go.
Some happens.
So if you and the folks around you got the answer, just erase it and try the next one. Yep. Oh, for the next one? Let's do it. Oh, excuse me, Lauren. Okay. Well, you're going to have to do in this one. What is tungsten is W? Well, tungsten's going to be 4.23 grams, and the other element is oxygen, right? And that's going to be what minus 4.23 grams? The 5.34. So you really kind of, and then you get the grams of oxygen. So you kind of skip the whole percent part. You just got to figure out the grams of tungsten and the grams of oxygen. And then you convert to moles, divide through by the smallest. So if you're working on number 3, realize they didn't give you percents. Instead, they just gave you the grams of the stuff. Good deal. That's right. Try the next one. And realize the next one is a little bit different. You have to figure out the grams yourself. They didn't give you percents. So you have to realize, okay, here's the grams of the W, and here's the grams of the whole thing. So if I take that minus the grams of the W, I'll get the grams of the oxygen. And now then you convert to moles and divide through by the smallest.
Okay. Thank you.
Yep. Okay. Oh, don't worry about sig figs. But that's, you could have just wrote 0.023 would be good enough. And now do the same thing with the grams of the oxygen. And then divide through by the smallest. Yeah, so then your final answer is going to be what for the molecular formula? Because you had C3H4O. Sorry. You had C3H4O, so it's going to end up being C. We get to multiply the subscripts by 2. So it'll be C6H8O2. That will be your final answer for the molecular formula, the chemical formula.
Okay, if Dr. Smith,
Yeah.
if it's that.
Okay. So now convert it to moles, and convert the grams of tungsten to moles. Divide through by the smallest.
Okay.
Mm-hmm.
I'm still confused on how you get this part.
Okay, so you got the empirical weight. You divided them. Okay, let's go by this guy. So you got 2. And you divided them out. So here was your empirical formula. Your molecular formula. Go ahead and write CH and the O down here. CH and the O. Now it was 3, 4, and 1. You're off by 2. So you have to multiply everything by 2.
Oh, okay.
And it's multiply, not add. So 6, 8, and 2. Because if you added up, you found the molar mass of this, you get 112.
Okay.
So that's your answer for molecular formula,
Okay.
or chemical formula of the stuff. So did you get it?
Yeah.
Oh, there it is.
Sorry,
C6. Yeah, good. You got it. Okay, we have a few more minutes. See if you can get this next one started. See if you can get this tungsten problem started. See if you can get that empirical formula. So you got the grams of tungsten, good,
Okay.
and the grams of oxygen.
Okay.
So now we're kind of in that game plan. We're at the part where we already have the grams.
Right.
Now we have to convert to moles,
Right.
then divide by the smallest.
Okay, I just want to make sure that I did
This is
right.
looks exactly right. Good, you got it. Now you just got to convert them all to moles. Oh, sorry. We just wrote down the wrong number. This is, the mass of the tungsten was 4.23, right? So you convert, so you're going to list out the grams of each one, the grams of tungsten, the grams of oxygen, convert them to moles. So you got this one right, grams of the O. Yeah, but the other one's, there you go, it's going to be the 4.23. Yeah, yeah. So it's going to be grams of the W, and then convert him to moles, the grams of the oxygen, convert him to moles. Then divide through by the smallest, and you got it.
Okay, what? Yeah.
Okay, so this is the grams of oxygen. So put a little G in there. Okay, and how? Right down here, the grams of the tungsten that you have. This one. So 4.23 G of the W's. Okay, so now where you are at in the game plan, Taylor, is you have the grams. So you have to convert to moles, then divide by the smallest. All right. So you look up oxygen 16. And hopefully you're getting WO3 for the empirical formula. I see that a lot of places. So that's going to be the grams of the W. You convert to moles, and then divide through by the smallest. Yep. Yep. Oh, that ratio, there's no units on it. It's just a number. Because the grams per mole both cancel. So you got about 2.1, you round it to 2. Yeah. Yeah. Yep. Okay, we're about out of time, but hopefully, now realize these in-class problems aren't homework. The goal of this was to get you some experience so that you, when you go home to do the homework that will be assessed, you have a better shot at getting it done. Right? So come by and ask some questions. Be glad to help you out. Have a good weekend.